So this time we're back to Simply Supported, and we are looking at UDL over the whole span. So it's quite a useful one to remember. This one comes up quite a lot. So this might be the self-weight of the beam, or it might be, standing for a crowd of people standing on top of here, 2 kilonewtons per meter, 200 kilos per meter. Yeah, crowd of people is pretty sensible. And so you might get a couple of people every meter. And so what are we doing? So the first thing is always to find the reactions, this RA and RB. Rather than go through it all, we just look at this one. It's got symmetry. There's no X in this one, so you don't have an X component. And so it's symmetrical. So you just find the total load, which is the area under the UDL, 2 times 5 in this case, which is going to be 10 kilonewtons. And then because it's symmetrical, and there's no X components involved, then the Y reactions at each end must be the same, so they must be 5 kilonewtons, because they've got to add up to 10 kilonewtons, and they've got to be the same, so just a bit quicker. So then let's just storm through getting the shear force diagram, and so the usual thing, so we know it starts at 5, so let's make this 2.5, 5, so this reaction, we have to follow that upwards first, for shear, positives upwards, and it's going to go up 5 kilonewtons, so it's going to start here. Then it's going to be a straight line, and for each meter we travel along, it's going to be 2 kilonewtons times 1 meter, so it's going to go 2 down, 2 kilonewtons every meter. Yep. Or we can say, look, we can go right to the center. Well, we could go right to the end actually, and we could say by the time it gets to the end, between here and here, if we're thinking about that distance, the change in the shear force is just the area under the shear force diagram, allowing for its direction. It's pointing down the way, so we're going to go down the way. And so it must change by 2 times 5 is 10 kilonewtons. And so therefore, by the time it gets to the end, it must be down at minus 5 kilonewtons. We'll just write them onto the diagram. And so the shear force diagram must look like that. And we come back up by RB, so we hit a force, so we have to follow it. It's going up the way, so it goes up like that to the end. And shade it. And put on the maximums and the minimums. So this is 5 kilonewtons, this is minus 5 kilonewtons. Too easy. Next bit, not so easy. And so when we were doing exams, it's, well, whenever you see the UDLs in an exam, your heart kind of sinks a little bit because they're always a bit more painful, but not impossible. All you need to remember is the change in the moment is that for any particular distance is going to be the area under the shear force diagram at that point. How could we do this one? Well, let's just go each meter. And so if we go along a meter, then this is going to have come down. So it's coming down 2 kilonewtons per meter. So that must be 3. So this here is going to be 3 kilonewtons. So the area here, as you just take the average of these, it's going to be 4 times 1. So it's going to have gone down 4 kilonewtons. For the next step, we're going to have 3 here. It's going down 2 kilonewtons per meter. That's what this tells us. So therefore, this here must be 1 kilonewton to get the area under this section. Then we're going to go average of those two. So 2 times 1, because we're just going from here to here. We could also calculate it from the start to here, whatever, but we're just going to go from here to here. So the change between here and here is going to have to be 2 times 1, which is 2. I need to put a scale on this because I've already forgotten what that was. I think this was 4, wasn't it? So positive shear means a positive change in moment. 4, yep. And then the next one is going to go down by 2, so it's going to be here. And then we're going to have to figure out this bit. And so that little area there, well, it's just going to be, so that must be a half a meter, 0.5. And so the area under there must be, it's the area of a triangle, half times base, 0.5 times height is 1 kilonewton. So it's 0.25. And so between 2 and 2.5, it's changing by 0.25. Try and use the right colour. Now, we could do that, keep doing that down the other side, but we know it's symmetrical, and so we can just mark on those points. Now, not very well drawn though. That should be in the middle. It should be about 0.25, which is probably nearer there, isn't it? Oh, no, because each of those is 2. So each square is 2. So this is, let's just put that on, 2, 4, 6. So that would be 7 divided into 4. So it's not very much at all. It's just about there somewhere. Now we'll draw a nice curve through all those points. To do that, you're always looking at the point ahead of where you are. Helps to draw. And you can turn the paper around as well. It's not so easy when you're using a computer screen. Oops. Oh. It's like surfing. You never look at where you are, you always look at where you're going. He said as if he'd ever surfed in his life, coming from Scotland. Shade it. And then mark on the maximum. And again, maximum, where's it occurring? It's occurring where the shear is 0. And so that was 6.25 kilonewton meters. Now, this would be a good one to check that point. So let me do that. So what I'll do is I'll take a section through C and just double check that we've got the right answer for that, because it was a bit finicky to calculate it, and then I'll come back. So I've done my check, and the answers of the check agree with the shear force and bending moment diagrams. Just one thing, I nearly made a mistake, so I didn't agree to start with, but just remember when you're doing these, if you've got a UDL, when you get to the moment part, just have to change that to an equivalent force and times it by the lever arm. I actually just calculated this and forgot to times it by the lever arm, but it's a moment, so you have to calculate the equivalent force for the line load on that side of the section and then do it as normal for any other force. So that all works out. One more to do, and then we'll get on to a tutorial sheet, I reckon. Maybe 2 more.